Welcome to the course on Future Internet Design and Service Quality and its 4 course modules. My name is Anna Brunström, Professor in Computer Networking at Karlstad University. In this lecture, I will describe the course setup and give you the background for the course. As mentioned, my name is Anna Brunström and I'm the course responsible for the course. Together with my colleagues Carl-Johan Grinnemo and Stefan Alfredsson at the Computer Science Department at Karlstad University, we will be your instructors for the course. Our colleague Per Hurtig has also provided part of the material. So the course consists of 4 course modules. Each one can also be studied as its own course. The first course module addresses reducing internet latency, why and how. In this course module, we look at how latency today is a dominating factor for application performance. We look at the different sources of delay and how they can be mitigated, paying particular attention to what is called buffer bloat and the use of active queue management as a mitigation for this problem. In our second course module, Quick and the Evolution of the Web, we have a look at how the web applications has evolved over time, what requirements they put on the network, and how the protocols of the internet has evolved to meet these requirements. We look also in particular at the new emerging Quick protocol, which is an important protocol for carrying web traffic as we move forward. In the third course module, we have a look at multi-access solutions. Terminals today often have access to more than one interface, allowing you to communicate over multiple paths. We look at the key techniques involved for multi-access communication and look in detail at some of the solutions. In the fourth course module, we have a look at Internet stack evolution, challenges and opportunities. Here we look at the concept of Internet ossification, how you have the ability to evolve the internet, and looking at transport services as a solution to this issue. So the course is delivered to you by the Computer Science Department at Karlstad University. The content of the course is also highly connected to one of our main research profiles within the department. So in the CS department, we have a strong focus on computer networking and distributed systems, and our other profiles are on security and privacy and also on software engineering. So within computer networking, work is carried out within the DISCO research group, the Distributed Systems and Communications research group. So within the DISCO group, we started to work on internet latency already 20 years ago. We were also one of the partners on one of the early framework projects within this area, RITE, Reducing Internet Transport Latency, where we looked at transport layer solutions and also interaction with the network layer. Through one of our PhD students, we've also had a very close collaboration with the buffer bloat community, and the buffer bloat community has been a driver for reducing internet latency over the last years, developing many of the solutions in this area. We've also had a national 5-year initiative to build a distributed research environment related to low latency internet, and this in collaboration with the RISE, the Research Institutes of Sweden, and Mälardalen University in Västerås. Work on latency has also been carried over in the Horizon 2020 project NEAT, and NEAT had as a target to look at the evolution of internet protocols and how you can introduce new protocols into the internet in a flexible manner, and also how you can configure communication to optimize performance. And within NEAT, we have worked on also the concept of transport services and providing the first open source implementation of this concept. The work in NEAT has also been a driver behind the standardization of transport services within the Internet Engineering Task Force. In NEET, we also looked at multi-access solutions, having a look at how you can select interfaces in an intelligent way and how you can configure multipath communication protocols. And the work on multipath communication has also been strongly connected to our work in mobile broadband networks and the build-up of a mobile broadband testbed in the Monroe Horizon 2020 project. So in Monroe, we built a European testbed for multi-homing performance in mobile broadband networks. So we have measurements node across several countries in Europe, and each node has access to multiple operators, so you can experiment also with communication over these multiple access techniques. The work on mobile networks is something that is also now carried over into the SCIENECE Horizon 2020 project, where we are building a testbed for 5G networks to experiment with the application performance and the support of 5G for new emerging services. Much of the work behind these lectures have also been carried out in a large national research profile, namely the HITS profile, on high-quality network services in a mobile world. And this is a research profile carried out together with 5 industrial national collaborators, which have also contributed input to these lectures. So let's return to the 4 course modules and the timing of the course. So in terms of the primary teaching activities, we will start with the module on reducing internet latency. We will then look at QUIC and evolution of the web, followed by the module on multi-access solutions. And finally, we will look at internet stack evolution. And the teaching period for the spring is 20 weeks, which means that we will spend 5 weeks on each of these modules. And this is in relation to the webinars that will be held in the course. As this is an online course and all the material is made available, you are of course free to study the material for these modules at any pace during the spring. However, some of the material for a module may not be available until closer to the main teaching period for the module. So in terms of the teaching platforms, all the course material will be made available on the course homepage, and here we will also continuously announce any updates and discussions related to the course. The webinars that will be organized in the course will use the Zoom platform. And to participate in these webinars, you should simply need to click on the provided link for each meeting and enter as a guest. And please make sure to have a functioning webcam and headset available for the webinars to have the best possible communication quality. So the course is provided in 2 versions. You can take it as a freely available online course to learn about the material, take part in the webinars and in the discussions. If you want to take the course for credit, then you need to be an officially registered student. And you then also need to turn in a set of written assignments connected to the course and also take an oral exam. And these written assignments will be administered through the Canvas learning system. So for each of the course module, we will have a set of teaching materials available. So for each module, there will be some recorded video lectures. This is supported by a set of related readings and sometimes also related videos or other links to other web material. For each course module, we will also have some practical exercises. And in addition, we will have some video interviews or other material from our industrial collaborators. This to also get some outside perspective on the content. As mentioned, in each of the modules, we will have some webinars available, and the idea here, of course, is for you to be able to discuss and ask questions about the material. The webinars will not be for lectures, as these are already recorded, but will be for discussion and interaction. And we will also have a course blog on the homepage, which is also used for discussions among the participants. So you are free to use this material and study it in your own order and at your own pace. We hope you will enjoy the material.